Today I'm going to show you our backboard optimizing feature using TigerStop's proprietary dynamic optimizing software. Now, this option can be purchased for your existing TigerStop or for a new TigerStop. Dynamic optimization, or linear nesting, is an instant and mathematically precise method of deciding what order to process parts to optimize material for yield. It determines the best solution for material, so your operator only has to focus on feeding the parts and cutting. So now I'm going to show you how this works. So to start with, we can either use our Tiger Touch or we can just use the controller. So for this video, we're just going to use the controller. So I'm going to select a list that I already have pre-programmed. Now keep in mind, we can always manually enter in our own list, or we can download lists from your cut bill using our TigerLink 6 software. So we'll run list 1. And it's going to ask us to enter in the clear stock length. So first things first, I'm going to make a trim cut on this piece of material. And our clear stock length is going to be right up to the edge of this board, because we can see we have no defects, 21 inches, and start. Now, the TigerStop is going to immediately come up with the best solution based on what's in this cut list to fit on this clear stock length. We'll put on our label. This will allow us to sort our parts later. We can put different numbers on here, such as position, quantity, our job number, anything that will make our job easier to sort our parts afterwards. Okay, so we're done with that first scrap piece. Now keep in mind, it's very important on the beginning of every job that we continue to use our scrap pieces first, use all of our worst pieces first, and then we'll start to use our full stock length. That will allow us to keep up with not having to sit on extra material all the time. So we'll set our next scrap piece up and we'll do our trim cut. And we'll look down the board, 29 inches. Once again, the TigerStop will come up with the best solution possible. Okay, so now that we've used up our scrap, we're going to go on to our full stock pieces. We'll do our trim cut. And I can see we have a split on the end here as well as a knot. So we're going to have our clear stock length at 54.5. And we can see we were able to fit 2 pieces and then right to the end of our split. And once again, it will ask us to enter in our clear stock length. We'll do our trim cut. And looks like we have a defect right here at 41 inches. We'll hit 41 and start. Okay, and the controller once again will ask us to enter the clear stock length. Now we're right at the end of our defect, so we're going to cut around the defect. And then we're right to the end of the board for clear stock length, so we'll type in 17 inches and start. All right, And so we would normally continue to do this until the screen on the controller would say parts list is empty. That'll let us know that our job is complete and we're ready to go on to the next job. So that's how backboard optimizing works.